Hey everybody, this is Larry. This is me going with Q3 of the weekly contest 233. Maximum value at a given index in a bounded array. So this is a binary search problem. I had a lot of struggles with this, mostly because of a typo that I didn't catch. And also I had some debugging code that I actually left in the submission. Whoopsie daisies. As you can see. But yeah, hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem. It's tricky, it's hard, it's fun. But yeah, so basically the idea is that, and I actually misread this problem a bit during the contest. I don't know if you have the same, but I thought that this thing, I thought that it had to be exactly 1. So what I mean is that I thought that it would I thought that like it could be a step ladder, which makes it really harder. But because it doesn't, it basically is a strategy, right? I end up doing this binary search, and what happens with this binary search is that there's a greedy algorithm for, let's say you have an answer and you're trying to figure out if there's a greedy way of doing it, and the answer is that, okay, you have let's say you have some index, let's say you have some index like here, and you have numbers to the left, numbers to the right, and you try x is equal to 20, right? Well, what happens is that if x is 20, then by definition the left, let's just focus on the right side for now. It's the same to the left, but you have to look at 20. Okay, 20 is too big, but okay, fine. Let's just do 20 anyway. 19, 18, 17, all the way down to 1, and then it's just 1, 1, 1, 1, 1, 1, 1, 1, 1, right? So that's basically the minimum that you can do. And the idea here is that if and you do the left side as well. The idea is that, okay, let's say you have a max sum that is really big. Then can you solve it using this, right? And the answer is that you can always add numbers to the right or left to meet max sum. You can do it, you done a lot of different ways. You could even make, you could do 20, 21, 22, whatever, right? All the way to max sum. I don't know. Some numbers so that it adds up. And you can always do this so that, because it could be, you can imagine this to be a bigger number and then on another thing, and then it adds together, right? So that's the general idea. And conversely though, if this number, if this number is really small, or at least really small compared to our sum, then you cannot reach max sum. That's the only impossible case, because there's no wiggle room, right? You cannot decrease, like every number here is set so that this sum is the smallest it can be given x is equal to 20. So that's basically the idea. And from that, you can notice that it is monotonically increasing. So it becomes binary search. And the way that I do it is, And there's a couple of mathematical formulas here, but that's basically it. This is binary search. If this is good, we go to the left. We go to the right, we set left is equal to mid, otherwise we, narrow the bounds. I'm going to do, I've been getting this request a lot lately, so I'm going to do a separate binary search tutorial. So I'm not going to focus on this part right now. Let me know in the comments whether you want to see it. If you want to see it, it motivates me a little bit more, so hit that like button and leave a comment. But basically, these are just all mathematical formulas from that point. Try to observe it and derive it if you have time. Pause the video if you like. But this is just the number of ones that we have on the left and numbers of ones in the right. And that's basically what I have extra, because they're just ones and we're forced to take those ones. And then this is just the left count. And this is, this formula is just, you can imagine 1 plus 2 plus 3 plus 4 plus 5, ... That's the formula. And so that's the formula for one part of it. And from start to end, if you kind of look at, plus 7 plus 8, you can think about this as, plus, say, just plus 4, right? And then to get from 5 to 8, this is how you do it. From 5 to 8, you take the suffix, which is from 5 to 8, or from 1 to 8, and then you subtract it from 1 to 4, right? So that's basically the idea behind here. You could work out the formula, you know, at home or later, and this is the left side and this is the right side, and that's pretty much it. And you know, from here, this will have O of log, you know, log h algorithm, where h is the bound, or u, say u is the, you know, where u is 10 to the 10 apparently. And for here, you can see that this is O of 1 operation, more or less. You know, yeah, I mean, yeah, this is just all arithmetic and math, and this is all of 1. So this is going to take O of log u times in total. So yeah, so this is actually independent of the in the number of bits, I guess. But yeah, that's all I have for this problem. Let me know what you think. And in terms of space, this is all of 1 because we only have variables. I guess I have to mention that explicitly. But yeah, you could watch me solve it live during the contest next. I had a lot of silly mistakes. So, you know, call them out, see what you think. And yeah, let me know. This was such an annoying, hard problem for me. I would also say that if you struggled, don't feel so bad. Because I know that my explanation and other people's explanation, and that's why you watch the videos, they make it seem easy. But that's why I want to show how I did it in the contest. And I did relatively okay. I finished 69th. And I took 20 minutes on this problem, and I more 22, 23 minutes, because I took a couple of minutes, I skipped Q3, and then I came back to it. So yeah, so even though the explanation is really easy, I think this is a hard problem. So don't feel so bad, and definitely, you know, work at it and break it down to pieces, and yeah, see if you can learn from my, you know, whatever. Messed up. Silly. Okay. That was dumb. Okay, so yeah. Length is n. Where I is, okay, so the thing is less than I, and the adjacent value is 1. Okay, I mean, so this is always going to be true anyway, as long as it's positive. The sum of the nums of index is maximized. Okay. Index is 2. I mean, this is just math, but it's really annoying math. Math and maybe binary search. Yeah, maybe I'll come back to it. Let's see if there's a minor type. Oh, I just didn't think it through all the way. Now we have to think about Q3. My ranking is pretty slow, but I am one of the few people who's getting Q4. So okay, let's think about this. This is a weird math problem I'm annoyed about. Maybe not annoyed about per se, just I'm bad at it. Okay. Can we do binary search on this? I feel like it's binary search, but this part is tricky. What does it mean, right? That means the left, let's say we want to try an answer. That means that the left, yeah, I spent way too long in Q4. I don't know how to do this one. So you have a step function. I need paper. Okay. 6, 10, 11, 6 numbers. So you have to start with oh, I misread this. I thought this was constrained by I. No, numbers of I can be anything. Oh, then this is much different than what I was thinking. Okay, I totally misread this. Because it doesn't have to start with 1 or... I think for some reason I thought you have to start with 1. So then now we can do a binary search much easier that way. Okay. Maybe? So we have a still... How do I... Okay, that's... maybe I still need a paper because I'm bad at this math. So, and this should have been a tip away because the index 1, so... let's see max... what does 3 look like? What does 3 look like, right? Okay. Numbers of I has to be a positive number, so it's at least 1. But it could actually... So we just have... Okay. So it is binary search, I think. So you just have decrementing all the way to 1 on the left and the right. And then, okay. And all the way to 1 left. Is that good enough? I also, for some reason, thought that this has to be 1 and not 0 or 1. So I was thinking about step that. I should stop explaining this stuff to farm. But okay. The n is in sight then. Okay. So it has to be positive. I messed that up before. 10 say. If this, we want the maximum, so if this is good, then we want left is equal to mid, else right is equal to mid minus 1. Okay, and then okay, so left is equal to index and right is equal to n minus index minus 1. What is good, right? So target on the left side is going to be the math is hard. So it's something like is it +1 or -1? I always forget which one it is. 5 times, no, it's -1. Let's just add a function. This is such an annoying problem. But a lot of people got it, so. Okay. So this is if we have 0 numbers, then this is just 0 on the left. Okay, that makes sense. Poop. What happens if this is 0? Okay. Okay, let's just say, so we have to go from right minus, so right is the number of items. Okay. Now is that, yeah, okay. Okay. I don't know. This is okay. So if left sum plus right sum plus extra, and I might be off by 1. If this is greater than max sum, if this is the minimal thing, then we return false. Otherwise we return true maybe, because if it's, so we can always go up. Maybe I'm off by 1 though. I don't know, this is so awkward. I don't think, I mean, this is still not right, but 20 left C, right C, extra. Okay, let's at least take a quick look. These numbers are ridiculously big, so let's do a for loop to C, to C, to C. Okay, so if the max number is 1, the left C is -1, which is probably not what we want. What are the inputs? So for index 2 and max of 6, if the first number is 1, then maybe this is, then we have 2 numbers on the left, and we want this to, that means that we want this to be 0. So this means this should not be -1 for sure. I mean, that's just awkward, but if this is 1, this should ideally return 4, but I return -1, so that's awkward. What is the okay, so if I can't focus, this is tough. Okay, so let's say that we're index 2, the 2 numbers to the left, we start at 1, so this actually should return 0 numbers. So how do I force? So this is T. So how do I force that to be 0? So T, so T, because extra would be, what is this? 2 minus 1, 2 numbers on the left, -1, so this is actually this, and then now we want to go to, what is the starting point, Larry? Starting point is T minus the number of steps to get to 1, so it's T minus left plus 1 maybe. So if left, why am I so bad at counting? Okay, so if T is 1, then we want to go 0 steps to the left. So actually we want the min of this and T minus 1. Why am I so bad at this? Okay. So, okay, so let's say we're at 1. Why am I so bad at this? We're at 1, so then we want to use 0 numbers. So, okay, so it's T minus this thing. Maybe? Okay, I mean, this is better, but the extra stuff is wrong, clearly. I wonder how that happened, but got the wrong answer because that's just weird. Okay. So 1, 2. What is the 2? Just for symmetry maybe, but that still should be wrong. Yeah. Okay, so now we're counting nothing because okay, so no, I think that's why I had this. I already had the t minus left. Okay, so the starting point is t minus left or 1, right? Yes. Why is this wrong? Lava. Because okay, this part is right, the extra is now wrong, maybe. Well, definitely, but why is extra wrong? So in that case, you have t minus left. So you have left numbers in the right? Okay, so if left is 0, then this is awkward. It's actually really awkward. Why am I so bad at this? If left... Maybe this was right all along. Nope. So if left is 0, then we want this to be... we want this to be at least 1 maybe? Yeah. If there's no numbers to the left, then this should net out to 0. So left is equal to 0, so that's t, and this should be 0. Why is this? Oh no, because left is not equal to 0. So we should go. So if left is 1, we go from 4 to. Okay, no, this should be right. Why am I getting -1 here? -1 is here only if this is t. What? Oh, I'm really bad at this. Left is 1, then this would be 4, 3, 2, 1. Okay, yeah, no, that makes sense. Why is this -1 then? Do I print something else anywhere? Because I get confused. No? Let's just do it. Because I am just very confused. Oh, what? Oh, that's why, because I'm dumb. Yes. Hehe, okay. I had to dumb it down for myself and print out everything literally. Okay, so this is better, and also this has the same issue. That's why. I mean, it may still be wrong, but it should be slightly better. 3 and 4 still. Okay. So this is now slightly better. Okay. So 1, we get the total sum of 3. Is that even right? It's an array of 4 elements, so the answer should be 4. So this should be this plus t, actually. Oops, no, plus t is here. Okay, 2, 3, okay. I can't believe I don't know if this is right, but it's going to take me a long time to debug anyway, so I'm going to YOLO submit. Okay, good. Oh my, so much silly. Like, yeah, thanks for watching. Let me know what you think about this problem. If it was good, bad, I don't know. This was an interesting contest. Let me know what you think. Hit the like button, hit the subscribe button, join me on Discord, ask me questions here, there, wherever you like. And yeah, have a great week. Have a great time. Stay good, stay healthy, stay well, and to good mental health. I'll see you next time. Bye bye.